All right, for the first one, you always look for a common factor. What's your common factor here? 6. Once you take it out, you don't have perfect squares. You just have x plus 2, so you are done. And so your answer should have been 6x plus 2. Number 2 looks like they started actually a grouping. This is what your groupings are going to look like. Again, you're going to look for a common factor. What is your common factor here? It's a binomial. Your group. Yeah, your group is your actual common factor, x minus 5. And when you pull that out, you will be left with x plus 7. Neither one of those can do anything else. Common factor in 3, do you have one? You don't, right? So we go straight to looking at that 12. Is this going to be the same sign or different signs when you factor this? And how do you know it's going to be different? The 12 is negative, right? Right? In order to get multiply to get a negative, one has to be positive, one has to be negative, all right? So we list all our factors of 12. There are 2 factors that should add up to -1. What are those? Yeah, positive 3 and negative 4. So your factoring should have looked like that. All right. For number 4, do you have a common factor? You don't, right? 1 and 81. What do you notice about the x squared and the 81? What should stand out to you there? They both have perfect square roots, correct? Perfect square roots that are subtracted is called the difference of squares. It is a special case. You take the square root of each and do the plus minus, the conjugates there. X plus 9, x minus 9, or order doesn't matter, as long as one's plus and one is minus. So for this one, do I have a common factor? No. I mean, other than 1, no. Do I have a special case? Yeah, I actually do have a special case here. Factors of 1 that add up to 2 are 1 and 1. Whenever they're the same factor, you probably have a perfect square trinomial. So if you look at this guy, x squared is a perfect square. 1 is a perfect square. When you multiply it and double it, you get your center guy. So your factoring should have been x plus 1, x plus 1. Or you can write it x plus 1 quantity squared. All right. So for the first question, do I have a common factor? Well, I have an a, an x, and a y. No, I do not have a common factor. So it's 2 terms with no common factor. So my next question is it a special case? In order for it to be a special case, it has to be subtraction. It is. Do we meet that? And they have to be perfect squares. In order to be perfect squares, my exponents have to be what? Yeah, they have to be even, actually, right? So 2, 4, 6, 8, and you have perfect squares. They are all 2s, which means I have the difference of 2 squares. So then I am just going to find the square root. Well, the square root, you just remember, divide your exponent in half. The square root of a squared is just a. The square root of x squared is just x. The square root of y squared is just y. And once I know my square roots, I'm just going to do plus minus. So I have ax plus y, ax minus y. So basically this section throws in your regular factoring with your special cases. And the key is to recognize that you have a special case. All right, and typically when you have factoring like this that has a special case, it's going to be your difference of 2 squares. So always, 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 your first step to do this is to factor out your common factor. So what is my common factor here? Between the numbers, my common factor is a 5, right? My variables, they both have an a, and it's just one a, so I can take an a out. They both have x's, but how many can I take out? Just 1 because of that second term. And this is the only y I have, so I cannot take out a y. So my common factor here is 5ax. I took out the 5, I took out the a, those just become a 1. I had 5 x's, I took out 1, so I now have 4 x's. Divided by 5a and x gave me a 1 here, but I didn't take out any y's. Now, often people will say, okay, I am done. But you are not finished here because you have a subtraction and you have 2 variables that both have even exponents. So you have a special case, don't you? You can take the square root of each of them. What is the square root of x to the 4th? X squared. What's the square root of y to the 4th? Y squared. So I'm going to then move and do a plus minus of that. So I'm going to say 5ax, that's going to stay out here. And I have x squared plus y squared and x squared minus y squared. Am I finished? Why not? I have yet another difference of two squares, don't I? Now, the first group cannot be factored. That plus cannot be factored. In order to factor, it has to be a minus. So that group is prime. All right, x squared plus y squared is prime. You cannot factor the sum of squares. There's no way to factor it. But that second group there is yet again a special case. We have a perfect square, and a subtraction. What's the square root of x squared? What's the square root of y squared? And so I have my 5ax. I have my x squared plus my y squared. And then I have x plus y, x minus y. That is factored completely. That is factored completely. So you have to be looking for, did I factor it completely? Think of it when you did fractions, right? When you reduce fractions, your last question is, can I reduce it anymore? And that's basically what you're doing here. You're saying, can I factor it any more than what I've already factored it? All right? All right, so for this one, you'll notice you have an x to the 4th, an x squared, and then something without an x. Now, the only rule here when you are factoring these trinomials, as far as your variables go, is they really have to be half of what's there. So if this is a 4, that guy has to be a perfect square root because it's going to be it times itself. And this one has to be half of it because I'm going to multiply, and add. So for this one, I'm actually going to set it up very much like I would set up just the x squared minus 9x plus 8. All right, I'm going to do it exactly the same, except because this is x to the 4th, these first terms are going to be x squared. X squared times x squared will give me that x to the 4th, and it will also give me my middle term that will add up to negative 9x squared. And so now I'm going to look for factors of 8 that add up to 9. What are they? Factors of 8 that add to 9. 1 and 8. Are they positive or negative or one of the other? They're both negative, right? Negative 1 times negative 8 is positive 8. Negative 1 plus negative 8 is negative 9. So they're both negative. All right. Am I finished? Group. So 8 is not a perfect square, right? This does not have a perfect square root, but 1 does. What's the square root of 1? 1, right? So I have the square root of x squared is x. The square root of 1 is 1. I have the difference of two squares. So I have x plus 1, x minus 1, and x squared minus 8. Now I'm finished. So first thing you do is look for a common factor. Do you have one? Yeah, what's your common factor here? 5. So we're going to take a 5 out. And then we are going to group them. So we're going to group the first two. When I group back here, I need to change that sign of my last one. All right? First group. What's my common factor in my first group? Y squared. And I'm left with y minus 3. What's my common factor in my second group? Just a 1. And I'm left with y minus 3. And so here, I'm going to have my 5. My common factor group of y minus 3. And what's left over is y squared minus 1. And what do I do from here? Right here, perfect square. Yeah, perfect square, difference of two squares. So I'm going to say 5. Leave your y minus 3 alone. We have a y plus 1 and a y minus 1. And that's what your answer should have looked like right there. Do I have a common factor? I do. What is it? 3. So I'm left with x cubed minus 2x squared minus 16x plus 32. All right. Again, we're going to group. And again, we grouped behind a negative. What's the common factor in my first group? X squared, right? We have x minus 2. What's the common factor in my second group? 16, and we have x minus 2. And so once again, we are going to take our common factor, write that out, our common group, and then what we have left over. And again, what can I do? Difference of two perfect squares, right? So I have 3, x minus 2, and this plus 4 minus 4, right? Any questions on that? Good?